For those of you guys just joining us in the video, we just went over this example really quickly again from yesterday, talking about these two different forms, two different variations of writing an equation for an ellipse. This one is much better for graphing by hand because you can go more easily to this form where you can know the over 2 and the up 3/2 in the other direction as well. The center is 0, 0, but this one is much nicer to deal with as a function for x-intercepts, for y-intercepts, for graphing in your calculator, etc. So they both have their own pros and cons. Right now the kiddos are working on this example I made up, just kind of straightforward before we go to another tricky example in a second of sketching an ellipse with an equation in the nice by hand form. And the calculator is probably going to pop up about 10 more times during class. Okay. What'd you guys figure out? Center's at where? Careful. X minus h is actually a positive 2. Easy to see. X minus h, so h is positive 2. Y minus k, so then 0 would have been the y value. So I have my center at 2, 0. Now, how do we start generating our ellipse? Have to find each of the radii, the horizontal one and the vertical one. We'll call them major and minor later. Horizontally, how much do I need to go out for this ellipse? 5. 1, 2, 3, 4, 5. So that's just going half the distance, right? So what else do I have to do? 1, 2. Go 5 the other direction as well, right? So I have 5 to the right. I have 1, 2, 3, 4, 5 to the left. How much up and down am I going to go? From the center, right? It's a question. Does this one have a major axis that is vertical or that is horizontal? Vertical. And how should we have been able to tell that? Actually from the equation, not even, or before we even graphed. Yeah, you just have to look at which one's bigger. With major and minor radii, it's just saying which one's the main, which one's the major, which one is dictating the orientation on this one. Since we have a vertical of 7 and a horizontal of 5, then yeah, we would say the major axis is 7. So if we were to identify things, this is kind of homeworky. If we were to identify the center, let's see, what else do they ask for? The vertices and the foci. Okay. We're doing an easier example. You have the graph. We already found the center from our equation. It's 2, 0. What's it referring to with vertices? Do I find all 4 edges? No, I only find the 2 edges of the major axis, right? So I'm going to find the top one and the bottom one. What point would this be if it's just extended upward from the center 7? Good, because the x stays the same, the y changes. And so what would this point be for the other vertex? 2, -7. If this center was somewhere else, like 2, 1, remember you have to, from that current y value, add the 7 and subtract the 7, so it's not always just plus or minus. You have to take the y value of the center and add 7 and subtract 7. That's all you're doing. So we have our vertices, but what don't we have? We don't have the foci. From our notes yesterday, how did we either label the graph? Because some of you guys put the clues in the graph about how to find the foci, or it would have been maybe you wrote it a separate note later. Where are the foci located, first of all? On the major or on the minor? On the major. And then what distance, because it can't be 7, those are the vertices. What distance do we go, or what do we find to go the distance for the foci? Yeah, what letter do we need? For parabolas, for parabola we need to find that p coefficient to go to the foci in the directrix, or the focus I should say. For ellipses, what's the letter? C. And what's the formula, Nathan, that you were talking about?
C squared equals A squared.
And who's my A, who's my B?
7 and 5.
7 and 5, so we can plug in. Well, technically, couldn't we just plug in 49 and 25?
Oh.
So we take the square, we can take the square. 49 minus 25 ends up being mental mathers. 24. Square rooting both sides. It's not a pretty one. But guys, just estimate. Square root of 24 is almost 5, because square root of 25 is 5, right? So it's almost 5 when I go to my graph, but for over here, we'll be all nice and say square root of 24. 4 goes into 24, 6 goes into 24. So the square root of 4 is 2. So 2 square root of 6 is like the really nice version. So when we go to put it in our, or put the actual points, the specific points, we'll use 2 square root of 6. But when we come over here to our graph, let's just go ahead and say that's 5-ish. So we'll go up 1, 2, 3, 4, 5-ish. Put one focus, go down 1, 2, 3, 4, 5-ish. The other focus. But what would the points be?
2, -5, 2, 5.
The x remains the same. The y is now 5. Now use the
2.
and then adding 2. The y value 0 plus 2 root 6, just 2 root 6. And then 0 minus 2 root 6. Just negative 2 root 6. Okay. Those of you guys that started homework should have started somewhere around here where they give you equations. And they give you clues pretty quickly, which is the example we'll see on the next page. But if you can find this nice form, if you can find your graph, then hopefully you can pull out each of these different characteristics just by kind of looking at it and knowing how the major axis works and where the foci are as far as being C apart. There are a couple of formulas that are helpful to know. Tyler. Yes, you may. Let's go see what happens when they don't give us a nice pretty equation. Ooh, but they do give us a picture. That's something.
Are we able to guess what the points are, or is that not allowed?
Sadly, no. You can estimate in order to check. So have you guys ever done like a math problem or an SAT practice problem? You've gotten an answer, oh, of course that's right, and then you check it, and no, I was wrong. And you would answer like, I don't know. Try to do this silly example. The base of a rectangle is a negative number, like it doesn't make sense. The base of a rectangle will never be a negative number. So Ricky, the graph can help you at least see if your answer makes sense, but it needs to be precise. Sometimes it's nice of the people making the examples in our textbooks, so this is where I stole this one from, to make it so it doesn't look like it's actually a 3 or -1, because then you know it should be a decimal. What's tricky in calculus every now and then is they put a point that looks like 3 and it's really like 2.876 or 2.934.
That's me.
Well, you can't trust the graph, but some people do. Okay, most of you guys should have your clues kind of written down by now. The nice thing about an ellipse is that you can automatically say, well, I want x minus somebody squared, I want y minus somebody squared, just like a circle, equals 1 because we're dividing by other quantities. Is there anything I can plug in? H or K or A or B? What do you guys see? Center, okay. So I can plug in my H is 2. My K is 1. What else do you see that's been given to you, either in the graph or in the wording up above, or both? I see one of these, and I see someone talking about a C. I like both of those. Those are the clues. But what does this mean?
They get you B or A.
Didn't give me A.
Half of it.
Didn't give me half of A. A is half.
Gives you twice the thing.
It gave me twice A. Does that make sense? They gave me, wait, guys, can you tell from the picture? Now, this is where you can use the picture to help your reference system. Is it wider or is it taller? Wider. So therefore, I can say the major axis must go horizontal and must have, if the axis is length 6, that's like the diameter, that's the whole length across. So I know the whole length is 6, so what do I know about A?
3.
A must be half that distance, so I can say A is 3. A is half that distance, so A is 3. So I can go ahead and plug, that's horizontal, right? Sweet. 3 squared. Put that under the X. Vertical, okay, I need what goes under the Y. Huh, they didn't tell me the minor axis length. So how am I going to do that one? We used that clue, we used that clue. What haven't we used? The foci. What do they tell me? See if there's anything you can use. Do you see anything? Do you see if there are any special constants? Or see if there's any special measurements? Does anyone notice I'm saying C a lot? C squared equals A squared minus B squared? I'm saying C for a reason and not just yes. C is the distance from the center to the foci. So kiddos, if they tell me the center is 2, 1 and the focus is 4, 1, I'm not trusting the graph, I'm trusting the points. If the graph measures up, what's the distance between x is 2 and x is 4? 2. So I know that C, I'm going to write red bones is messy. C equals 2. I know that C equals 2. And how can I use that to find B? Some of you guys are already rattling off that equation. So what is that equation? C squared equals A squared. Minus B squared. If you think about it, it's really just Pythagorean theorem, but I need C to be less than A. I need C to be within A or inside the shape. If it's outside, it's actually just a straight line. It's a degenerate conic. The foci were outside. So there's subtraction, A squared minus B squared. So I end up with, wait, I know what C is. What is C?
2.
So 4 is equal to, A squared is 9 minus, I know the trouble, B squared. With a little bit of quick math, hopefully you guys can see that B squared equals to 5. Ew, so B is equal to plus or minus root 5. It would just be positive because it's a measurement. And what do we need to plug into my formula anyway? Is it B or is it B squared? So don't even worry about that. Take the B squared and say, oh, sweet, okay. You can square root the 5 and then square it again when you plug it in. If you say, oh, I want B squared to plug in. And we can end up with x minus 2. Is that a good equation, guys? Yeah, it's a great one. If you needed it to be in that graphing calculator, either you wanted to check it in your graphing calculator or you need to find something in your graphing calculator with it, you could go ahead and multiply both sides by 45. You would end up with 5 times the first, 9 times the second. That is another form. I just multiplied both sides by 45. But I'm pretty sure the book agrees with me that this is a great one to keep for most of the answers, okay? Now, you guys do a quick favor for me. Can you go ahead and turn to section 10.2, the very beginning when we had the double nape cones. Remember you guys like all these pictures that basically almost no one drew, but they're really cool if you did draw them. 10.2. Okay. Did you write down the standard form of a conic section equation underneath the pictures? Is the parabola section underneath the pictures? It's like a, how's it go? AX squared plus BXY plus CY squared plus DX plus PY plus, oh, F is a constant, equals 0? How can I make that bottom one look like that? What would I have to do? Yeah, get the right side equal to 0, so I'd move the 45, but what would I do? What do you mean, Maddie, distribute? But you can't multiply the 5 and the 9 until PEMDAS. You do the exponents first. So I have to square x minus 2 first, square y minus 1 first. And are we going to kill the puppy as we do that? Is that legal? No, that's not legal. How do you multiply x plus 3 squared? Or how do you multiply x minus 2 squared?
Well,
You got to FOIL. X squared minus 2x. X squared minus 4x plus 4. You got to FOIL it out. And then could you make it match by simplifying? Match that big old long one. No trust? Ashley, what's your question? You're okay. Okay. No trust, you guys. Or are you just like, this is beneath us, we got this. Move on. Y minus 1 times y minus 1, FOIL and combine. X minus 2 times x minus 2, FOIL and combine. Then bring in the 5. For those of you that are like, why can't you just bring in the 5? Well, first PEMDAS says exponent before multiply, but second, if I bring in 5 and then square, it's like I brought in 25, and that's not what's written. So then we go ahead and have 5x squared. I'll do the next term that'll be the right. Ax squared. Bxy isn't there. Cy squared, I'd write the 9y squared second. Plus dx, there's my minus 20x. Plus ey, there's my minus 18y. Plus f, well, I have 20 there, I have 9 there, that would be 29, and I'm subtracting 45. Wouldn't that be, can I make it look like that standard equation? The answer is yes. Why on earth am I spending time on that?
the next page,
What is that? There are no fractions. There are no perfect squares. There's no a squared, b squared, x minus h squared, y minus k squared. Break it down. We got it. We got to get the squares ourselves. But how? Move 37. He's not working. And say, okay, the standard form makes all the x's and y's be the squares and the squares and the singles and the singles and the constant. But don't we want the x's together? And the y's together? Okay. So we're going to take the x terms. There's an x squared term and a single x term. We're going to write those two together. Then we're going to write the y squared terms together. And moving to 37 because he's no good. He's bad, he just doesn't really help us in our goal. Okay, that's in your standard form equation that we're trying to get to. Isn't my goal to have x alone with an h squared? And y alone with a k squared? Now I'm making it a squared and b squared. Maybe this isn't the major. Maybe the major will be on the other side. But that's the idea. That's what I want to make it look like. Or else, how am I supposed to do anything with this by hand? You can't. You need to make it look like it, my by hand form. So,
You group 9x squared.
can't I say I have x terms and y terms? Let's group them and deal with them separately. Decent or negative? So what's shared in my x terms? You guys kind of like
9 and x.
we could pull out a 9x. And if we were just grouping, I would totally agree with you. But if I want to get this,
Yeah,
just the 9. Does that make sense? I want an x squared term, or else I can't factor to a perfect square trinomial. I want a perfect square trinomial, just pull out the 9, keep the x squared. Need a perfect square trinomial to get a square down here for x minus h squared. I don't know, that's a perfect square trinomial. That's just a square. What's shared between 4y squared and 40y? 4. I want the y squared term to stay 10, sure, why not? I want to complete that square. equals. If I'm getting ready to add in stuff, I better get ready to add it in on this side too, or else I'm going to have my equation be all unbalanced. And we know from other classes besides math, it's important to have a balanced equation. You're welcome. Question. How do we find the term to fill in for completing the square?
Half the middle square and then the
Middle
square.
term, cut in half. And
Square.
The other side.
it's -6 cut in half is -3. -3 squared is 9. So why am I putting in an 81?
Because 9 times.
We're just going to have dots over here for me. Just trying to get dots together. Because I have a 9 on the outside, so when I add in a 9 on this blank, look at the bigger context. One little decision might make a bigger impact. Ooh, we're better for that. So then, following the exact same pattern, what number did you guys end up adding over here?
25.
25, good. 10 divided by 2 squared. I know it's getting worse. I don't know what's going on. It's academic. Why am I adding 100?
Because it's 4 times 25. Okay, so we did this in order to be able to complete the square. And we did it. Who was squared to make 9? And there's a minus because it's -6x. Who was squared to make 25? 5. And we did it because, well, I'm doing addition because it's a positive 10. And then on the other side, 181 minus 37. 144? 144.
Ooh, that's nice. Hold on, standard form. I just erased it. Do you guys remember? This one equal to 0 is standard form, but this one, what needs to be on that side?
1.
How do I? Don't subtract, divide. I want denominators anyway. And guess what's nice about 144 and 4 and 9? 9 into 144, 9 into 14 is 154, carry it. I end up reducing to 1 over 16. 4 into 144, 4 goes into 14 3 times, 24, 6, 36. I forgot my square again. Reduce, 9 goes into 144 16 times, 4 goes into 144 36 times. It took us a little while, but this is golden. This is prime. It's ready for us just to go graphic.
We're not even done.
No, super close. Come on.
We still have to find the center, the very center.
But what is the center? It's right there staring you in the face.
3 negative 5.
1, 2, 3, 1, 2, 3, 4, 5. Center, check. What else do we need? How far to go right and left? No problem. 1, 2, 3, 4. Got it. Left. 1, 2, 3, 4. Got it, because that's my A. What else do I need?
Where?
Oh, 6.
1, 2, 3, 4, 5, 6. How far to go up? Oops, that's not the center. How far to go up? 1, 2, 3, 4, 5, 6. How far to go down?
-6.
Now the nice thing is this one didn't even ask me to write the different points out, but if it did ask me, no problem, we can write them all. Our center, our vertices, our foci. We'll just use our cool little forms from adding 6 to -5. We'll get 1 vertex up, keep the x, 3. -5 plus 6 is 1. -5 minus 6 is -11. But my foci, I have to plug into a plug. And I have to go ahead and do c squared is equal to a squared minus b squared. Nathan already said square root of 20 and he's right, which is 2 root 5. If you guys notice, all we got to do is take our vertex and say keep the 3 and do -5 plus 2 root 5. -5 minus 2 root 5.
Thank you guys for keeping your distractions quiet. But you got it, kiddos. 10:23. Have ready for tomorrow. Fully attempted as much as you can. At least 75% for that spot check. Bye. Eccentricity.
Oh, yeah.
Well, don't worry. There's only one or two. That'll be the 75%.
Yeah, we can't do homework, Misty.
No,
Call it
just
off.
do it tomorrow.
Oh no. Call it off.
I said you can skip the last two eccentricity ones.
I was probably gonna skip the last two anyway.
I was gonna skip the last like 5.
I was only planning
She
on
only
doing
said
it.
75%.
Yeah, we only had 75% of them done.
Oh, really?
For tomorrow.
That's the rule?
Spot check.
Oh!
Because you're allowed to have a couple questions.